Okay, 1 2 1 2. Should be live. Okay, yes, we are live finally. Excellent stuff. Okay, that should be all good now. We are green in OBS. 6K BPS, 6K kbps per second. Mic is working. You can see me. So, how's it going? Right, let's just wait for the live chat to pick up a little bit. JD Sound 180, what's going on, my man? Good to see you here, bro. Yeah, do you wanna share the YouTube link with some of your followers as well? What's up, Adrian? How's it going? Robert, how's it going? Boomatronics, what's going on, bro? A little bit of Friday evening entertainment for you. Thing is, yeah, I'm tempted to plug in this. I'm tempted to plug this in on stream, but I don't want my PC to turn off, bro. Do you know what I'm saying? I'm tempted to plug this in on stream, but I don't want my PC to turn off, you know. Yeah, no, this can take too long to set up. So on my bench, I have this PV powered mixer, which I've actually done a little bit of here and there on previous live streams, but finally got all the parts arrived for it. And something funny for you guys, I'll just explain. So we've got the amplifier board here, which has all been rebuilt. And before I plugged it into mains, so this amplifier was actually dismantled by the owner. He took it apart fully and he actually unscrewed a bunch of stuff on the board here and found blown transistors and blown resistors, and then he was like, oh, I don't know what I'm doing here, I'm going to pass it to somebody who does know. So because it was already dismantled and like stuff was unplugged already, after I repaired the board, I was left with this spade connector here, which was unplugged. So I'm plugging all this stuff in over here, and I'm plugging this auxiliary supply voltage tap from the transformer back in, and I see this and I'm like, okay, well, where did this go then? So I'm looking around, I can't see any spade connectors on the main amplifier board here. Obviously got a couple of spade connectors over here that come in from the mains. This is live and neutral. And then I see these. A couple of spade connectors just here, and these connect to ground. So I'm like, oh, well, this just must be like a center tap for the secondary or something that you're supposed to connect to ground. And the length of this cable here actually just about works to go over to here. So I went ahead and connected this over here to ground, plugged it in, and the mains plug socket in the UK, each plug socket has a switch on it that cuts 240 volts from the switch. So each plug is switched basically. So the switch was off. So the plug was essentially off and not live. But even though the plug wasn't live, the second I plugged in this mixer, my RCD tripped to my house. Turned on my PC and my workshop off and everything. So it's like, why did that happen? The plug wasn't even on. It's almost like I had no fuse in it, but it still happened. Like there was no connection from live to the amplifier, but still it tripped my RCD. So I thought it was just a fluke. Maybe a capacitor had some residual power left in it. I don't know. So I went and flicked it back on, and then I tested it again, and it tripped it again. So why is this happening? Why is it tripping my RCD? It's not even connected. It's not even powered on. And then, but I've just been sitting here looking at this. I've just been sitting here looking at it and thinking, why could this be? And I was thinking maybe this isn't supposed to connect to ground. Unfortunately, there's no photos online or anything like that I could look at to determine where this goes. And you know what I think it is? I think that this is actually a optional live wire if you're using this device in 110 volts region. So what I was doing essentially by connecting this to ground is I was connecting part of the primary to ground which explains probably why my RCD was tripping. What's going on, Brandon from Arizona? How's it going? Oh, by the way, actually, can everyone hear Donnell? I've actually just realized. Can everyone hear Donnell? Because I don't think I set up an audio source for you. Say something and I'll just check to see whether it's... Okay, I don't think it was. Now I have actually set that up. Say something again.
Yo, yo, yo.
There we go. Now you're coming. Now you're coming. Okay, so you should be able to hear him now because I've just unmuted desktop audio, so you should be able to hear him now.
No,
there we go. Yeah. There we go. It just takes a minute. Trust me, bro. Started the stream when you're like muted the whole time.
Probably a good thing the RCD trip. That's what I said to you as well.
Low volume though. Yeah. How's our voices? Are they even, or are you quieter? Let me try turning this up a little bit. No, okay, that doesn't make a difference. I might just increase. I might just increase the gain on filters here of desktop audio. Okay, I'm going to increase you by 2 dB. Hopefully you don't clip.
Hopefully.
Yeah, I think that's probably about right.
On my end. Yeah, it looks pretty good, bro.
Yeah, sounds good. Wicked. But yeah, how's things been going with you, man? What have you been doing in the audio world recently?
Been messing around with the lab grouping.
So this is... Yeah, I've seen some pictures of this amplifier. Me and Donnell have been chatting a little bit about this amp. So you've got your hands on essentially a 12 kilowatt PA amplifier. And I was expecting like 12,000 watts from an amplifier. Seems absolutely excessive. I'm very used to PA amplifiers topping out at like the sort of 3 to 5 kilowatt mark, and that's just coming from my introduction to PA amps, which was like with the Crown Macrotech series, and my Crowns are 2,000 watts RMS, and that was always massive to me. I was always like, damn, these things are beasts, I could power anything with these. But when you consider against car audio, 2,000 watts really isn't that much these days. And so when you then approached me with, like, hey, I've got this amp that's like rated like 12 kilowatts or something like that, I was like, that's ridiculous. But I thought about it, and I was looking at my Taramps HD 15K, and I was like, actually this output section here is 15K, and it actually does make 15K, similar to the Powerus and similar to a lot of modern amplifiers these days on the car audio market. That amplifier stage can be the same in a mains powered amp or a car amp. It's just the power supply section is different. So then I asked for some pictures of your lab grouping, because 12 kilowatts, I was expecting, hey, this has got to be a Class D, because otherwise the thermals are going to be ridiculous. And yeah, you showed me inside, and it's actually sort of based around Class AB. I think it's Class H, is it?
You said it was a SMPs, isn't it?
So yeah, the amplifier stage in that lab grouping, that 12K, it's sort of class, it's not Class AB, I think it's Class H, but it's based around Class AB, so it's output transistors rather than MOSFETs, emitter resistors, and it's a linear amplifier essentially. It's like mostly linear. It's not working with PWM, so the efficiency is going to be quite poor. So I was thinking that's ridiculous. I don't think that amplifier is going to make rated power, but you have proven us wrong.
Well, we have got doubters, but the way I was going through the fuses that day and blowing them in seconds, yeah.
So yeah, in the UK here we have 240 volt mains, and the maximum fuse rating that you'll generally find in household appliances, well, the maximum current rating for a mains plug, like a standard mains plug. Yeah, so this is the standard UK mains plug, and the maximum rated current for these is 13 amps. And you can do the maths on that. 240 volts times 13 amps, and you were constantly blowing 13 amp fuses. And bear in mind, a 13 amp fuse isn't going to instantly blow at 13 amps. It will actually allow a lot more current through than 13 amps. It will only blow at 13 amps continuously for probably quite a long time. Like a continuous load of 13 amps, it would eventually blow. But it can easily pass 20, 25 amps in a short burst. And I think the combination of your SMD AM M1 and also the fact that you have one of those wall plug power meters that tells you how many watts you're drawing from the mains plug on a certain device. That trips out at how many amps?
So the meter, it will trip out anything past 20 amps. So anything from the straight on 20, bang on 20.
Yeah.
You can trick it sometimes 24 until it kicks in. So we know it does a minimum of 20 amps.
Yeah, exactly.
Obviously,
Yeah, the fact that it's blowing a 13 amp fuse relatively quickly means that you're in
yeah,
excess of 20 amps by quite a bit, and also the fact that it's tripping your power meter means
yeah,
that it's well over 20 amps. Now, obviously, this not being a Class D amp, it will be relatively inefficient compared to a Class D amp. So if you're going to be getting like 12 kilowatts out of the amplifier's speaker terminals, you're going to be drawing like 16, 18, got to be from the wall, and with the power factor being whatever it is.
I knew it was a lot of current due to the fact that you can hear the 50 hertz hum at the breaker.
So that's a great video you sent me. You got like the 40 hertz like stop go on your phone like this, and you're standing by the freaking breaker, and it's like crazy stuff.
Literally.
Yeah. So
it's crazy to see. You don't normally tend to see high powered amplifiers that are class AB.
well, no, that's why I was really surprised when you pulled the top off and sent me a picture of it. I was thinking this has got to be peak ratings. Like surely not. Surely something that's this much power would be Class D, because something that's going to demand that much power is usually low frequency application, where the classes of the amplifier will impact the sound less and less as you go lower in frequency. So it would make sense just to make it be Class D, especially with how we are with Class D now. Modern Class D is actually incredibly clean, and the best Class D designs can actually rival or outperform a lot of Class AB designs now in the kind of SQ world. So we have the technology, we have the circuit designs there for Class D to be incredible sounding, so really there's no reason not to use it. So that's what surprised me, that it wasn't Class D. While you've been playing this amp on some subs that you've got, and has it got really, really hot? Obviously, I imagine it will do.
So I've got it to go into thermal. So these amps, they don't really protect. A light will come on and then it will start limiting itself back. But I've got it 80 degrees at the exhaust.
80 degrees.
And I tested it with the heat gun.
That's absolutely ridiculous, guys. To measure 80 degrees on a heatsink, that means that the actual silicon die on those transistors will be like significantly higher than 80. The fact that you've got 80 on the heatsink, because the further you go back to the heat source, the hotter it's going to get. Now, when you look at data sheets for electronic components, you will have two separate ratings, like current ratings usually, one for 25 degrees Celsius usually, and one for 100 degrees Celsius. So parts will continue to operate in excess of 100 degrees, but they will change their specifications drastically. Obviously, much lower current handling due to higher internal resistance, and also their switching parameters will be different. Now, this is a linear amplifier, so those characteristics are less important, but that's still crazy to me that they've made something like this that is so powerful, that generates so much heat.
But I've been talking about this with my servo a lot, like amplifiers, but how long they can sustain power without thermal limits. What gives with that?
Well, what I imagine that the thought process behind this amplifier, this lab grouping thing, with it being Class H, we're going to call it Class H. It's not Class AB because it switches the rails. It's not Class TD, I think they call it, which is just marketing. It's going to be a form of Class AB that switches the rails as the signal increases to improve efficiency. But I think yes, this amplifier can produce that much power. As you have proven, it can't produce it sustained without overheating. But what I think it is it's the amount of, in order to produce that much power, this sine wave will be able to swing up to obviously the required voltages to produce that much power. But given this amplifier into its intended installation, the impedance rise from the kind of drivers and cabs that it would be driving, and also the dynamic music load that it would be that it would be driving, would mean that yes, it needs to have the voltage headroom space that it would need to make 12 kilowatts, but it's not actually going to make that power in its normal intended application. So I don't think the overheating would be a problem in its designed use case. In a rack, powering.
The crazy thing is, so the fuse that was in that plug has survived 3 carnivals.
Well, there you go.
A few venues.
Yeah.
And they use it across loads of different bass bins. So,
yeah.
Obviously, with Rise, they get it to clip, obviously, with the Rise, but it's not enough to blow the fuse. Obviously, I'm coming here and giving it resistive loads.
Yeah, exactly. And that there proves my point. So this amplifier is used up to its limit. So it's used up to clip point, but because of the reactive loads that it's being presented with in the PA environment, it's not doing the kind of current that you're subjecting it to with car audio drivers and the resistive loads. So in that instance, yes, although it can't make its rated power continuously in resistive loads on a test bench, it actually does perform its required task in its designed environment. So, in that sense, it's a win, really, and that's cool.
Yeah. But like we see with amplifiers, like how would you have an amplifier that would sustain for longer? Do you just have one that does it at a much higher impedance?
So if you wanted to try and say, for example, you wanted to try and design an amplifier that actually can sustain 12,000 watts, without overheating. Okay, what you need to do is you need to be able to think about it like a heater. You need to be able to get rid of however much power in heat it's creating due to efficiency losses. So let's say, for example, you have a Class D amplifier design that outputs 12,000 watts. Let's say its efficiency when making the 12,000 watts is 75%, okay? So that means, I can't do the quick maths in my head. Let's make the numbers nice and easy. Let's call it 10,000 watts. So that means that you've got to get rid of 2,500 watts, if my brain maths is correct. So you've basically got 2,500 watts worth of heat that's being created, because in order to make the 10,000 watts or whatever it is, you're using up 12,500 watts. So you've got to get rid of 2,500 watts worth of heat. So yes, provided you can get rid of 2,500 watts worth of heat in some heatsink design, then the amplifier will then be able to, continuously provide the 10,000 watts without overheating, because your heatsink design is getting rid of that extra energy as heat. Whereas in this case, with the Lab Gruppen, to make 12,000 watts, it's Class H or whatever it is, the efficiency is going to be very poor. So it's probably needing to get rid of something ridiculous like 8,000 watts worth of heat at that sustained load, which it naturally is can't do.
Because what I was trying to get at, and I could be completely wrong, is it current that heats up our circuit?
What heats up a circuit is it's essentially current. Yeah.
So I was saying, like, let's say we had an amplifier that could do all this power. Let's say like 16 ohms.
Well, it's not just current. It's basically power. So I know what you're saying, in that if you had an amplifier that made 10k at 16 ohm versus an amplifier that made 10k at 1 ohm, would the heat output from those be different because there's less current going through the 10k 16 ohm amplifier? And no, because in order to make 10k at 16 ohms, the voltage needs to be monstrously higher than the 1 ohm amplifier, and so the wasted power in order to make the 10 kilowatts, the efficiency losses are still the same. So current,
it always works out the same. Okay,
the amount of heat that an amplifier is going to generate is not how much current; it's how much power is being wasted in order to generate that output. This is where GaN FET amplifiers are so exciting, because with the new semiconductor technology, GaN FETs that are not using silicon dyes, they're using gallium nitrate dyes, they are a lot more efficient. Their internal resistances can be a lot lower and they can be switched a lot faster. So you are going to end up with these kind of ridiculously powered amplifiers, 10 kilowatts, 12 kilowatts.
These GaNFETs, they don't dissipate hardly any heat.
Yeah, they're gonna require very little heat sinking compared to your conventional silicon diode devices. There's already, I think it is a 200 watt or 250 watt GaNFET amplifier that produces rated power with no heatsink on the die, no heatsink on the output devices. And that's like, what? How? That's mind-blowing. That's crazy.
Do you think we are from GaNFETs being like just roaming the market and within car audio and home audio?
I'm interested to see what the first car audio amplifier is that uses GaNFETs. I don't know if one already exists. I generally only see stuff that comes in because it needs repairing. So if a company releases a new amplifier and it's reliable, then I might not actually get to see anything about it for like quite some time until one goes wrong. Because I don't go seeking out, I don't go buying or asking companies to send me new things for me to review. I'm just a repair guy. So I get experience in amplifiers when they fail, and when they fail repeatedly, I get to see a lot of them and get used to them. But given where we are, the infrastructure to convert the factories from using silicon to gallium nitrate in their semiconductor devices is actually not that difficult. So I'm hoping within the next 5 years we start to see some stuff come on the market relatively affordable that's gallium nitrate.
Yeah. What's that Cargo said?
There we go. Sound Digital makes some GaNFETs already. I had that in the back of my mind. I thought Sound Digital had jumped on that. I haven't seen any of them yet. I don't know if any of them are even in the UK yet. It would be really cool, obviously, if I was able to get one on the bench and do a video on it. That would actually be a great video. I don't particularly want to go out and buy one out of my own pocket because I won't make the money back from the video. My channel isn't big enough for that. But if they want to send me one, or if somebody wants to send me one to do a detailed review of and go over its efficiency compared to silicon-based amp, that'd be sick.
We need to get you one of them amps.
So let's have a quick look in the live chat. Didn't Clarion have small amps that were Class H? Yeah, we've also got Vibe Audio in the UK here released an amplifier that was Class GH, Class H. It switched the rail to a higher rail potential as the signal level went up. I think that was designed by, I might get this wrong, I feel like it was designed by one of the guys behind original Zapco. I've got a feeling that was pretty cool amp. Yes, and this was another thing I wanted to touch on. So when you first showed me the Lab Group and amplifier, and you told me, hey, this is like 12,000 watts RMS or whatever, I thought that, well, in order to make that much power in such a slim amplifier, surely it must just be rectifying mains voltage and just using that as a rail. But it's not. It's actually got a switch mode power supply inside, which also is mind-blowing. That firstly they would put that in there because surely the voltages that they're creating for the rails aren't that far off of what rectified mains voltage would be anyway.
I was topping out, like you said, around 195.
Yeah, so rectified mains in the UK, you rectify 240 volts, you get about 320, 340 volts DC. So obviously you split that in half for two rails. So yeah, this we're fairly similar. So I was surprised that it had a switch mode power supply.
I was shocked as well when you told me. I was more shocked when you said to me it was not a Class D. That was what I was more shocked about. Yeah,
and it doesn't look that big either. Like when I checked out the board at yours. Yeah, I mean, I
love how they hid. I love how they shoved two caps underneath though.
Yeah, they did. Yeah, then the IGBTs in that switch mode power supply are doing some freaking work. I'll tell you that much.
Yeah, because how many was there? There wasn't a lot.
Didn't look like there was a lot. IGBTs are crazy though. I want to see. I'd love to see a car amplifier built, or just an amplifier built using the same type of IGBTs that are used in electric cars, EVs, Teslas, to run the drive motors, because those drive motors are like 100 kilowatts per motor, or even more. And they are driven by, it's the same very similar kind of circuitry and process to an audio amplifier. They're driven by motor inverters that use IGBTs, whatever, to send pulses and send different waveform shapes and stuff to the drive motors in different phases. So the basis is very similar, and it'll be jokes, you know. We definitely have the parts available here to make, you know, 100 kilowatt car amplifiers if we wanted to. It would just be a bit of R&D and a bit of trial and error. How's it going, Ryan? Good to see you there, buddy.
I need to get you the switch and frequency of that amp.
Or the lab grouping?
Yeah.
Well, it's not Class D, so there won't be any switching frequency.
On the SMP.
On the switch from power supply. Yeah. Just be careful. I'm not sure. You'd have to isolate you have to use your battery powered scope probably for that, so you can probe it with a ground reference. Well, that's good. I'm gonna be a little bit careful.
Yeah.
Have a job getting 100k of speakers in a car, to be fair. You'd be surprised, some of these big builds using like 6 or 8 modern drivers that can easily soak up like 8, 10, 12 kilowatts per driver in a burp. You know, if you've got some of these modern like Windmaker 4-inch 8-layer coil car subs, okay, these subs on a burp can soak up 10 kilowatts per coil, in excess of 10 kilowatts per coil. As Donnell knows, you've put more than 10 kilowatts into a 4-inch coil. So if you're chasing numbers, if you've got like 8 subs, all of a sudden a 100 kilowatt amplifier is kind of what you need in order to clamp absolute maximum power to these 8 subs that you've got and put out the highest number, you know?
Yeah.
But but you know, that kind of level, you're talking about audio drag racing essentially. It's not musical, it's not listenable, it's literally just a test of power and a numbers game. It's like, not at that point, it's nothing to do with music really. Yeah, people have been doing 100k builds. Exactly, yeah. People have been using multiple amplifiers to do more than 100k for years. Exactly. You look at the likes of Alan Dante, for example, doing ridiculous numbers of power. So, but to be able to get that in one amplifier, not have to gain match and stuff like that, and obviously the space constraints, or being able to use multiple of these amps would be pretty cool.
Yeah. That's what I was going to ask you as well. Explain to me what you were saying earlier about subwoofers that can take a lot of power at high frequencies without bottoming out, and how inefficient that actually is. It's not actually a good thing.
Yeah, no. So you sent me a video of one of your subs that you've got taking pretty much what that lab grouping amplifier can deliver, and that subwoofer voice coil, the 4-inch voice coil, was clamping like 8-10 kilowatts across the coil, and it was free air. And that was mind-blowing to me. So because free air, the driver, when it's in free air, it's not pushing against any air spring. It's not driving a port. It's basically like a motor free spinning. Yeah, so it's like you just lift up your EV and you just press the accelerator pedal and the motor is just free spinning, right? So obviously, when a motor is free spinning, it doesn't have a load attached to it. It's not drawing any current because it's not actually doing any work. So for you to be able to clamp 8 or 10 kilowatts to a free air driver at like 40, 50 hertz, the fact that you can do that without it destroying itself mechanically, that instantly tells you that, hey, this driver is horribly inefficient at those frequencies that you're playing, because the fact that you can get it to take that much power and it's not destroying itself mechanically means that all of that energy is just going into overcoming, firstly, the moving mass of that driver being so high, and also the ineffectiveness of the motor to coil relationship between the coil and the motor at that frequency. The fact that all that power is just disappearing, where's it going? All this happening.
I prefer it up there, because when we play like in the lows, 500 watts is all it takes for it to bottom out.
Yeah, exactly. So that's where those drivers are happiest, and that's where those drivers are best used, is in the sort of 20 to 35 hertz range. That's where they want to move. That's where the whole kind of pendulum motion of the cone and the resonance and everything works for that driver. So to get that thing to destroy itself mechanically, on lower frequencies, 1000 watts is all it needs. So that's where you want to take that driver and put it into a build and make use of that motion, that kind of resonance, to drive a port, or to compress the air in a seal box, or compress the air in a cabin. If you're asking these modern drivers to play 40, 45, 50, 80 hertz or whatever, so much energy that you put into the driver is just being lost in the driver's own losses, because it just doesn't want to play these frequencies. And so that's what got me onto wanting to I've been wanting to make a video for years now, going over low pass filter and how everyone basically has it set too high for these modern drivers. If you are not starting to attenuate off your amplifier's power to these modern drivers at like 35 or 40 hertz, if you're asking the amplifier to throw the same amount of power into these modern drivers at 45 hertz as you are 25 hertz, then that is horribly inefficient, and that is causing your driver to heat up way more than necessary, and you're not getting much out of it at those frequencies with that much power anyway. So I want to make a video I don't want to talk about it too much here, because I want the video to have examples and show evidence and show proofs and show power graphs and all this. I want to do all the experiments to actually showcase this, that people should be setting their low pass filters way lower than they currently are with these modern drivers.
My low pass is 30, 32.
Yeah, exactly. Yeah, in my builds, I think my low pass filter in the Proton is like 30 something hertz. But that's because my T-line door cards kick in at like 53. So, but even so, with these modern drivers, they just want to play lows. That's all they want to do. And I'm
happy it does it at the lows.
Yeah, there are drivers that you can buy. I say modern drivers, I'm grouping modern drivers all into one category, which is not correct. There are modern subs, obviously, that you can buy that are happy playing upwards of like 60, 80 hertz. But the most sort of stuff that you see people buying, all the kind of Edge Pro stuff, the Vibe stuff, the Def Bonds, Sundown stuff to an extent, the bigger Sundown stuff, a lot of these like big powerhouse woofers with big heavy cones, big heavy coils, massive surrounds, they just don't want to play these higher frequencies. The only exceptions I can think of is some of the slightly older digital design stuff with the really tight coil gaps and very, very light moving mass. Those actually are very happy playing, and that's why digital designs was always used in DB drag, burping like 73 hertz, because hey, it's really happy up there, just because of its tolerances and the weight differences and stuff. It's closer to a PA driver really, and also FI audio, just due to their tight tolerances and the way that they're built, they are better at playing slightly higher than a lot of these other modern drivers.
Yeah, that's crazy. But I think it'll be good for you to explain coil sizes and their power handling. What's your view on that? Because there is a lot of like different opinions out there.
Yeah, I mean, it's difficult. You can't make a broad statement about one voice coil size as such, because how much power a given coil takes in a given driver, there's so many factors that will contribute to how much power it'll take. There's too many variables. You can have the exact same voice coil and take it from one driver, one motor. You can take it from one motor, one driver, put it in something else with a different motor and different cone, different spider and stuff like that. And that driver, even though it's got the same coil, will take more or less considerably than the driver it came from. But just as that, you tend to see power ratings for 3-inch 4-layer coils in the region of 1200 to 1500 watts RMS. If you see a 4-layer 3-inch coil that's rated for 2 kilowatts or more, you got to be skeptical of that. It's not going to really take that for very long, unless the motor structure is very open and it's a very, very strong motor. Then you will need a 2 kilowatt or greater amplifier in order to get the most out of that sub, because impedance rise will be so high because the motor's stronger. But as a general rule, 8-layer 3-inch coil, 2000, 2500 watts RMS, and then a 4-layer 4-inch coil, 2.5K, 8-layer 4-inch coil, 3.5. But once you start getting
these are continuous numbers, right? You're saying?
This is sort of how much power you can expect to not continuous sine wave, but how much power you can see clamped across the coil at points during music from that sub without really getting too much problem. Yeah, it'll heat up and whatever. Or a coil is just a heating element, so it will heat up, but you shouldn't run into that danger of blowing it. But depending on what the motor is and what other characteristics the driver has will change what amplifier you need in order to extract the most out of that sub. So if you take the if you take a voice coil from like a Edge Pro sub, for example, and you might be feeding it with a 3000 watt RMS amplifier in order to clamp like 1800 or 2 kilowatts, and that sub is getting hot and starting to smell. If you take that exact same coil and you put it in a Digital Designs DDZ3 motor, and you run that same amplifier, all of a sudden the sub is staying stone cold and you're just hitting clip point before the sub's really getting going. Even though it's the same coil, because the impedance rise will then be so much higher and the cooling is so much better that you need a higher rated amplifier in order to actually make the most of that and actually clamp the same 1800 to 2 kilowatts. But now you've got so much more driving force because the motor is stronger, so the whole thing will be a lot louder. So you think by using a bigger amplifier, you think, damn, this sub can take a lot of power. Actually, it's not taking any more power than it was. It's just using that power better because it's got a stronger magnet to push against.
But you know, a lot of these tests you see online, people that testing RMS on subs, one thing that they don't show is smell. When I do my test, it's stinking. You smell it bad. But you think, it takes that power, no smell. No, trust me, it's stinking. You
need to get that Smell-O-Vision camera freaking HD.
There's some 4D Subwoofer reviews.
Yeah, that's true. Yeah, I mean, crazy. I don't watch a lot of like sub reviews and stuff, but I don't think they've ever really said about whether it smells or not.
Yeah, like when I was doing my test, the room stinks badly. Didn't do that without having problems like that.
Yeah. But the sub didn't change its characteristics after that. It still played and behaved exactly the same.
I'm pretty sure its TS parameters would have changed because of the heat.
That'd be interesting. Have you DATSed it before you did this like big hot test? Did you DATS it before you did the test?
I haven't DATSed it, but that's a good idea.
Yeah. That'd be a cool video idea for you. One of your other drivers that you've got that's like freshly rebuilt. Make sure it's broken in. To break it in fully. Yeah. That's it. Get a baseline reading of the parameters, and then absolutely hammer it and get it smelling, like get it really, really hot, get it smelling, but don't obviously risk like the coil unwinding or expanding or anything. Just get it really hot, so it's really been hammered, and then let it cool back down again and see if the TS parameters have changed at all.
What an AES rating the power sub can take without its TS parameters changing? I think I had this conversation before.
I'm not sure actually. That's one thing I don't know.
I think I read up on it. And AES is the power sub can take. You see it on mostly PA subs. When the parameters don't change that much.
Bassaholic in the live chat actually, that's a good suggestion. DATS it while cool and then DATS it while hot. That'd be a good, DATS it 3 times. First, fresh but broken in. Second, while it's cooking, roasting hot after you've abused it. And then once it's cooled down and to see whether it returns to its original parameters or not. That'd be really interesting.
I'm going to do that, definitely. That'd be a good video.
Bevis, could you at some point, when you have time, do a video on 6th Order Series bandpass and how to design one on Bassbox Pro? I could, but if I'm perfectly honest, I'm not the best person to do that. Although I can design a series tune 6th Order and it will probably sound fine, that's not my area of full expertise, so I wouldn't want to make a video like that when I feel like there are other people who have a lot better experience and knowledge in enclosure design than I do that could make that better video. For example, Hexibase, for example, Hardwood Acoustics, and I'm sure there's many others that would do a much better job than me. So I wouldn't, yes, I could make that video, but I feel like it would be half cooked compared to what somebody else could make it. If it means me taking a camera around to Hardwood Acoustics and making that video with him, sure. But yeah, I don't feel like I have the expertise to make the kind of video that I want to make and for it to be as accurate as I'd want it to be, because that's just not something that I've played around with enough. I've built 6th Orders here and there a little bit, designed them, done a few boom or bust things, but I haven't built hundreds of sixth orders like I have repaired hundreds of amplifiers, so I'm less knowledgeable in that.
I still think you should do it though.
But I just explained to you why I do, why I don't want to do it.
No, I still think you should do it.
But why?
I think you're putting too much of what your skill set in yourself. I think people.
The problem is, so okay, let me click my brain into, okay, now I'm going to make this video about sixth orders. My first thing that I want to do in my brain, if I'm going to make that video, is go and sit down and talk to Hard Acoustics. And then I feel like that's basically just his video told by me. I would have to do a bunch of research myself to make sure that what I'm saying about series tuned sixth orders is correct. Like, I could reel off a bunch of information that I believe and that I think I know about series tuned sixth orders, but the knowledge isn't strong enough and the confidence isn't strong enough about that knowledge in my head that I could reliably be like, yeah, this is exactly how, without me being like, is it though? And I don't want to make a video that's like, is it though? And then in a year back, look back at that video and be like, man, I was chatting so much shit like I've done in the past. Like, I want to make sure that whatever videos I put out, the information is actually accurate and that I'm not going to come back to it in 2 years' time and be like, damn, that was wrong.
Yeah, no, I feel that. But I feel like everyone starts from somewhere though, innit?
Yeah.
You can't just go on the internet and be a perfectionist, you know what I mean? Everyone has their journey. Yeah,
and I just know what I know what I know. So I don't want to make a video about something that I don't know. I'll go and learn it, but it'll be 6 months or whatever maybe of me experimenting with series tuned sixth orders in order to gain the experience and knowledge that I would need to make that kind of video, and I just don't have the time to do that. So
yeah, it's crazy.
Matt said, when you did a video on T-line boxes years ago, use the saxophone as an example. Was that accurate? Yes. That video that I did in the garden with the various examples of enclosures, parts of that are accurate, parts of that are not accurate. The comparison of the comparison of a wine bottle to a ported enclosure, it's sort of half kind of correct, but not really. And there are things that I talk about with the sealed box with the drum is not quite correct, because with the drum it's like both surfaces are resonate. There's lots of vague things in that are kind of not quite right, but have a little bit of validity to them. But the part about the T-line and the quarter waves, yeah, it's accurate. It's very basic, and I definitely could have and should have gone into more detail had I known the kind of detail that I'd need to go into back then. But the foundational principles are there, and I think it helps people to think. It helps people to grasp a basic understanding of how a T-line is functioning differently to other enclosure types. So it still stands up for that. That's why I've left it up there. But there are aspects of that video that aren't quite right. What happened to your Scale 3D printed box series? Yeah, so Boom or Bust was really fun. I really enjoyed doing that. I was hoping to get more video views than I was getting on it, and I probably just need to persist with it. But the videos were actually costing me more money to make than I was getting, so I just had to kind of like put that on the back burner for a bit, because I was just spending a bunch of money making those videos and not actually getting the return on that. So I just wanted to kind of take a step back and look at Boom or Bust and think, right, what am I doing wrong here? How can I make this appeal to a wider audience? I think a bit of it actually might be that my channel isn't blacklisted as such, but I feel like the YouTube algorithm views my channel as an old ass dated channel that isn't really ever gonna suddenly pop off into the limelight. It's just one of these slow burning channels that kind of gradually gains subscribers. Honestly, I think that the algorithm definitely has some channels in a category like that, and I wonder whether I created a new channel just for Boom or Bust, a fresh channel just for Boom or Bust, and re-uploaded series 1. That's actually an experiment that I want to do, is make a Boom or Bust YouTube channel and just see whether that channel pops off better than my series did on my own channel. And if it does, that would then prove my point. So that's maybe one thing that I will try, and just see where that gets me.
That's a good idea, actually. The good thing is now is a lot of us do have 3D printers in here, so we could speed up the process for you.
How so?
Because how many boxes can you print in one day from people?
I think boxes. I think typically they print it overnight. So I mean, I could do 2 a day probably. Like set up one before bed and it's done in the morning, and then set up another one for the daytime. I could probably print 2 a day, but I wouldn't be able to make that many videos. You know.
I thought that.
But yeah, I definitely do want to have Boomer Bust back. I mean, I get comments about it all the time. People are always asking me about it. It seems like there's more demand for Boomer Bust to come back than there ever was views. Like I think some of the Boomer Bust videos topped out at like 8,000 views, which is literally nothing, guys, in YouTube terms. I was generally hoping to get like 50k views per video, and that would have paid for itself. But yeah, could you try editing those videos and doing them on TikTok and YouTube Shorts? Again, I did think about that. That's another possibility that I could do is do it in a different format. I wouldn't want to do YouTube Shorts. YouTube Shorts are limited to 1 minute. It's just not long enough. But TikTok, yeah, 10 minutes. And people, surprisingly, there is an audience on TikTok for 5-minute plus videos, because my repair content on TikTok, I also make repair videos on TikTok that are really kind of fast paced, and people are watching that stuff for like 8 minutes. So yeah, there is a demand for that.
The thing with me, yeah, is that you've had to reality check me so many times. Obviously, for me coming from TikTok, fast paced. When I post that video on YouTube, how I was expecting it just to rack up in like 20 minutes.
Yeah. It's a different. Yeah, it's a different mentality with YouTube, and the stuff cooks a lot slower on YouTube. On TikTok, I know it does happen on TikTok sometimes when you upload a video and it will sit there doing nothing for ages. Then all of a sudden, like a year later, it will go crazy. But it's less common. TikTok generally, you put a video out and it has that big reach initially, and then it just kind of tapers off. Whereas with YouTube, it is definitely a slower cook on there, and people favorite.
Yeah, you definitely told me about that. Definitely, because if it wasn't for you, the videos I'd be posting wouldn't be on there. Literally.
What is there to talk about head units really, unless they're amped? Was that in response to another comment, or somebody was saying maybe do like head unit reviews or something?
That's what I want to ask you. So, know that when you
hang on a minute. Yeah, sorry, just real quick. Bass boost. More head unit reviews would be good. I would love to see more of them. Yeah, that would be another potential take on it. I could definitely do, but I wouldn't be able to buy head units to review, so I'd have to get in contact with companies, see if they want to send me bits and pieces in to review them. And there would be stuff that I could go over with head units aside from the amplifier sections, like I've done with the Atoto and stuff like that. Just how accurate the features are, the usability. A lot of people don't really go into like annoying niggly things about the user interface or connectivity problems with Bluetooth and stuff like that. So I feel like I'd probably be able to do relatively decent reviews on head units. So, but yeah, sorry, what were you saying, bro?
You know, when you did your head unit review, how did you manage to get the waveform that shows the different sound signatures of the different modes on the head unit and that?
Also, with the Taramps head unit, I think that's what I did on that one. So literally, yeah, what I did was I just I in Audacity created a 20 to 20 kilohertz sine wave sweep, and then I fed that into the head unit's input, and then recorded the head unit's output in Audacity into a separate track. And so with Audacity, obviously the waveform, the viewable waveform, is relative to the signal voltage, right? So obviously if the output from the head unit was dead flat and it matched the sweep that I was giving it, so the sweep that I generated was dead flat, exact same amplitude throughout the sweep. So if the head unit wasn't altering that response in any way, then the recorded waveform would also just be dead flat, same amplitude across the whole thing. But obviously it wasn't. So then you were able to see where the amplitude reduces in the middle, like the smiley face EQ curve. You had the high amplitude at the start where it's low frequency, and then it comes down to low amplitude and then goes back up high again. So yeah, I just literally recorded the waveform in Audacity, and then with that recording, I could then drag and drop that recording into an analyzer tool that could analyze the frequency response of that audio file and tell me about it. So
yeah, no, I was impressed when I saw that, because how you managed to do that, I was like, how did you manage to do that?
Yeah,
crazy.
That was a good visual representation, I think.
Definitely.
There was one comment up here. There's a couple of comments I just wanted to go over here. More head units would be good. I have a theory about newer amps being designed to make power on the dyno, but not for much longer. So the only reason an amplifier wouldn't be able to make power for much longer, like it can only make it in a burst, but not for like long, it is just because of the thermal management, so it would overheat. So to make power on a dyno, the dyno test is longer than a dynamic burst. So a dynamic burst test will be a few milliseconds. It's like a few cycles of the sine wave, and that uses a lot of the energy stored in the rail caps to do that. And that's why dynamic power can be a lot higher in amps that have massive banks of rail caps. But to make power on a dyno, the dyno test is long enough to fully deplete that and to make full use of all of the power supply circuit. So the only reason that an amplifier would make less power over a longer duration than a dyno is if it reaches its thermal limit, which, yeah, you do see, but it's not really super common. What would happen if you built a sixth order with both chambers being exactly the same, both ports tuned the same? Yeah, you would have an enclosure that loaded the cone of the driver so hard that I think actually the output would be a bit restricted. I think you'd be loading it too much. A bit like if you have a really strong motor that can, a motor that turns. If it's a really strong motor, you're like, oh yeah, like I want to bend some drive shafts with this or whatever, and you put a massive thick drive shaft on it. It wouldn't be able to kind of turn enough. It needs to be able to turn a little bit in order to. I don't really know how to explain that, but I think that, well, at one frequency, at the tuning frequency of the ports, the driver would be pretty much dead still, and you would have the ports obviously doing their thing. But I don't think it would actually be as loud as if you tuned the ports slightly off from each other. Let's say we're aiming for 30 hertz. Let's say you tuned one port at 28, one port at 32. I think that would actually be louder than tuning both ports at 30.
Fair enough. What Connor said, heat dissipation is becoming a real issue for a lot of amps these days, especially 5K plus. What would you recommend, Sam? Just more thermal mass, bigger amps,
but
rather than going smaller.
Better designed heatsinks. Like if we're talking about car amps here, I don't know if we're talking about car amps or PA amps, but if we're talking about car amps, the heatsink is entirely passive. Yeah, they have fans in them, but the fans aren't actually blowing over the heatsink in an effective way. They're just like these tiny little fans that just blow a little bit of airflow across the internal surface mount parts and stuff. Yeah, there isn't really any proper good heatsink designs in modern car amps. They're more passive heatsinks, and they're just using the case as the heatsink. So the solution...
What would you recommend they'd use? What design?
Like something more similar to what you would find in a PA amplifier, where you've got lots and lots of like very thin fins with high surface area and good fan airflow channeling through them. Something like that. That's what's seen on the Crown JBL A6000 GTI, for example. That is a very powerful amplifier for its time. And if you actually look at the amplifier board heat sinking, it's tiny. The amount of mass for the heat sink of the amplifier stage is very small, but it's very thin fins and it's good airflow channeling across them. So therefore it's effective. So if you applied that same principle to a Taramps whatever Smart 8, and you gave it much better heat sink design, then it wouldn't overheat.
Crazy. So I'm taking it you could get if you was to keep pulling current from a Taramps, you'd get that to overheat eventually. I
don't know, probably. I don't think that the like the Taramps, like for example the Taramps Smart 8, I don't think that case, that heatsink case, is capable of getting rid of, I don't know, so if it was clamping 8K, it's probably sucking back 11K, so, or 12K, it's probably, that heatsink has got to get rid of a good couple of thousand watts worth of heat. I don't think it can do that.
That's the thing. Amps will do power, but it's just how long for.
Yeah, yeah. But fortunately, you know, in their designed environment, in their designed application, you never really have an
You never need
amplifier
to do that.
making that much power for like longer than a whole minute, you know, continuously. It's going to have a break. It's going to have a bit of the song where that note isn't playing or something like that. So yeah, it's about
That's a
average.
good one.
It's average
Water
power
cooled.
over time.
What about water cooled amps? Does that cross your mind? What Sherry just said.
Yeah, water cooled amps have been a thing in the past. There was a brand that did water cooled amps and subs. Didn't really take off. It wasn't as effective as they'd hoped, I don't think, or maybe the implementation of it wasn't that great. But I don't think that water cooling is necessary in a car amp. Water cooling is good when you've got a very, very small but very intense source of heat. But with a car amplifier, the parts that generate the heat are plentiful and spread out, and the device is quite large as a whole. So it's way easier to just build and implement a air-cooled heatsink for that would actually outperform something that was water-cooled, because it's a water cooler still has to have a radiator and a heatsink to get rid of that. The reason that water cooling is effective in computers, for example, is because you have obviously the dies, which are very concentrated hotspots, and so you're able to get a very big heatsink that would be like on the case with 3 big fans on it. You're able to get that to cool a very, very tiny thing, being the processor die, and you wouldn't necessarily be able to fit that much heatsink on the die directly. So that's where it becomes useful. It's just about taking that heat and getting rid of it in a bigger place, whereas that's less necessary for car amplifiers or amplifiers in general.
I remember you showed me the it was pretty cool. You showed me a massive subwoofer coil that the actual water ran through the coil.
I was literally going to mention that next. I was going to say the only time when water cooling might actually be viable in audio would be if the actual voice coil wire itself was hollow and water cooled internally, and there are coils obviously in industrial applications that are built like that have water running through the insides of the coil winds to cool them, and that, you know, if you were trying to build one subwoofer that can take like 50 kilowatts or 100 kilowatts, yeah, that's what you'd have to do. It has to be like a 10-inch voice coil with liquid cooled wire turns. Yeah, Bazooka was the brand that did it. Yeah.
Bazooka. Yeah,
Straight up, how's it going, my friend? Seems like a conversation I'll have to go back and watch from the beginning. Yeah, I can do. Yeah, or you can just jump in here. Had any experience with the Edge EDB 500.1 or any of that line? EDB 500.1. Trying to remember what one that is. I've had loads of Edge amps on my bench, and the newer kind of Edge amplifiers, not that great. They have potential. The foundations are okay for it to be an okay amp, but they're very poorly optimized, and the 4 channels specifically suffer from an assembly flaw where the silicon that they use to secure down the output inductors emits fumes that break down the lead-free solder, and there's a bootstrap diode just next to the inductor on one of the channels, and I've repaired maybe like 20 of them where the bootstrap diode is just loose because the fumes from the inductor silicon have corroded all the solder and it just falls off. So there's lots of silly, stupid issues like that with the Edge amplifiers. Incorrect switching frequency for the power supply, incorrect source for the power supply driver supply as well, and when you turn the amplifier off, it kills all the output FETs. There's lots of design flaws and unoptimizations with those. So I've always thought ferrofluid in speakers was a marketing scam. Not really. So you find ferrofluid in tweeters mostly, and the beauty of the ferrofluid is that, so if you've got a voice coil in a gap, okay, in a motor gap, the only way that voice coil is getting cooled is either by air passing over it from it moving in the air itself, Okay, and also it's also able to dissipate heat by dissipating heat into the motor, but in order to get heat into the metal of the motor, it's got to first get through the air that's between the coil and the motor. And air is a very poor conductor of heat, as I'm sure you know. So with ferrofluid drivers that have ferrofluid in where the coil is, the ferrofluid allows the voice coil to still move, generally at higher frequencies, obviously, without splashing around like you wouldn't use a ferrofluid in a subwoofer, for example. But with the tweeter, the frequencies are high enough and the movement is minor enough that you can put the voice coil in ferrofluid, and then all of a sudden, you've then got a really heat conductive, a really thermal conductive fluid that's touching the voice coil and touching the motor, so the heat can pass from the coil to the magnet of the tweeter almost instantaneously without having to get through the air first. So therefore, the thermal handling of that voice coil is now exponentially increases, like 10 times more power you can put through that coil, because it can get rid of the heat a lot quicker. So I don't think it's a marketing scam, to be honest.
Okay, continuing on with that, Sam. So you got subwoofers where they're vented at the back of the magnet, yeah, and you got def bonds who have nothing at the bottom. I think I had this conversation before where I've covered up the bottom of the vents on the sub, and they took more power for longer without overheating. And that could be, is it because the air has to come back around the coil again to escape?
Yeah, so designing the vents in a subcoil is not actually trivial. It's not as simple as like, oh yeah, just drill a hole here and if I get send it, it'll be fine. That's why companies like FI have such great subs and they perform so well and they can take so much power, because they actually design the cooling properly in their motors. So what you've experienced there, when you, I think I seem to remember the conversation we had about that. I don't think it was that it took more power. Wasn't it that the impedance rise drastically changed or something? I didn't think it was that it took more power. Maybe, but either way, by covering the main center pole vent there, when the cone compressor comes back in, okay, all of the air that's around the coil and that's basically behind the dust cap, with the vent open, the air that's behind the dust cap has really easy free way out, just down the pole vent. Whereas when you block that, the air is then going to be forced and pushed down by the coil and around the coil and then back out through the spider, which is transparent. It allows air through, basically. So by blocking the pole vent there, you are forcing the air that's being pushed and forced by the back of the, that's behind the dust cap, past the coil, therefore probably cooling the coil a fair bit rather than it just escaping out the pole vent. The downside to that is that the air that's being forced past the coil has resistance, so it's harder to push that air past the coil.
And that's probably why def bonds they're quite noisy subs, because they're sealed at the bottom. Yeah,
if you don't have a pole vent, then you're going to have a really a high mechanical noise, because you're going to have all that chuffing sounds of the air being forced past the tight coil gaps. But in some applications, in some drivers, they choose to have it like that, for whatever, they've designed it like that and it cools that way. But others will prefer to have the characteristics in the way that the sub moves. They prefer it to have the vent, or they just put a vent in because they think it needs one anyway. But the benefit also of not having a pole vent is, now this isn't the case if you just cover it, but if you don't have a pole vent at all, if the pole is fully metal and doesn't have a hole in it, then you can actually saturate that pole with a lot more magnetic energy. So if you've got two motors that are the same size, but one of them's got a pole vent and the other one has just a solid pole, then the one with the solid pole will actually be a stronger motor, because that pole can be saturated with more magnetic energy, because there's more metal in the pole. That's why all the DDZ motors are not vented. They have to be solid poles just to accept the amount of flux from the Neo.
Yeah, no, I never thought about that. That's a good point. It's a very good point.
I have ferrofluid tweeters and they burnt out pretty fast. Yeah, I mean, they're still burnt out, but I imagine that if you had two identical tweeters, one with a ferrofluid in them and one without, I suspect the one without would burn out quicker.
Sam, what's your favourite sub that you've used?
That's a loaded question.
Let's not talk theoretical. Let's talk about what you've used.
Out of what I've used, probably the Audio System Xeon 15s, man.
I don't know what they are.
Do you remember the yellow subs, yellow 15s in my Proton years and years ago? Audio System Xeon 15s.
Oh, okay, yeah.
They were like yellow Kevlar cones.
And why did you like them?
Because they were stupidly musical and they took loads of power. I regret selling them. I didn't really realize how good they were. I knew that they were great. It sounded amazing and they were freaking loud as hell on very little power. I didn't realize that they were like a really good brand. Like the branding, Audio System, that just sounds like some knockoff cheap brand. You know what I'm saying? Oh, Audio System. Like so I wasn't expecting anything from these subs. I put them in and I was like, yeah, these are great. These are pretty good. And I thought that I upgraded from those. I actually downgraded, but I thought I was upgrading to DC level 4 15s. They were whack. They sounded nowhere near as good, and they got stanky in like minutes compared to my Xeon 15s. So I was gutted. I was like, damn, these were actually great. And looking back now, they were amazing sounding. They played rock music, man. What modern car subs do you have that can really keep up with like rock music, light lows and stuff?
True.
So yeah, I have the big regret for selling those. I didn't realize how good they were at the time, and they're probably my favorites. Oh man, it was like 2011 or something. I don't know.
Oh yeah, long time ago. Crazy.
I did really enjoy my RE Triple X 15s. They were just really nice, smooth sounding subs, but yeah, they weren't just all rounders. The best all rounder definitely has got to be these Xeons. Freaking awesome. And obviously I have a connection to my Pioneers and stuff because they're the subs I had, but you know, at the end of the day, they're not actually that great sounding on higher bass and stuff. They're not on paper, they're not great subs. They're just really cool and they're nostalgic. What about you? You've had quite a few subs, yeah. Do you have a soft spot for anything?
I like that bass face sub, the little 8.
What was that?
The bass face one, the 8, the Evo 8.
Oh, okay. Did I see that? Okay.
Yeah, I like that one.
Mm-hmm.
That was pretty nice. Apart from that, it's just a sub. It's just
a sub. You don't have like a heartfelt connection to anything. You know, there's like something that got, well, I mean, maybe when you're my age, maybe when you're like mid-30s,
I don't think I'm old enough yet to have that.
Yeah, you'll probably be like, oh man, the In-Phase XTs are fucking wicked, man. I'm sorry.
No, I can't say that. I can't. I'll get cancelled if I start liking my own brand. So I have to choose another one. But yeah, I did like that bass face sub, and I like the Neos they did as well.
Okay. I don't think I ever saw the Neo subs they did. So aside from In-Phase, DB Audio, bass face, you've had a bit of experience with B2. I know that they mechanically failed pretty quick.
They were great subs though. They sound great. It's just not enough glue on them.
Yep. You've had a little bit of experience with some DDs. You've seen some of the DD Redline stuff. Have you had hands on with the DD Redline?
I've not had hands on with DD.
Okay.
I should.
Have you what about any of the old school stuff like Sony Explode, Pioneers? I mean, you've obviously had hands on with the Pioneers at mine, the 212s and stuff like that.
Before I started doing Sinewave, I used to just play around with like
Logitech.
Like the Logitech, the cheap Panasonic CD changer systems, and then the one with the blue speakers and the fake tweeters and that. That was me.
Yeah, is it me? Hey, anybody else in the live chat? Does anybody else agree that the most fun that they had with audio was when they were just getting into audio and playing with the really cheap home theater, like 6-inch, 5-inch subs, like hi-fi speakers, free air, stuff like that? I feel like I had the most fun with audio, messing about with just cheap home theater, mass-produced crap, building boxes for them, making them sound a bit cool, wiring a bunch of them up in parallel.
I think it's because we didn't know how it worked, so it was more wondrous.
Yeah, and I feel like, I don't know, it just kind of hit different.
Yeah, definitely.
Till this day, I still mess about with those. Yeah, jokes. Yeah, bass tech. Playing with your parents' house speakers. Yeah. 4 woofers, 6x9s. I currently have a Logitech Z623. Yes, those are great. Actually, very, very impressive for their size.
That was my first system.
That was your first system, yeah. A lot of people had like the Z2300 and the 5500 as kind of like their introduction.
Do you know, I always wanted to try out the Z5500.
Yeah, yeah. I've heard the Z5500. A friend of mine had one. Yeah, it's powerful. It sounds like a little bit laggy, kind of like it's tripping over itself. To me, the 2300 actually sounded better and played a bit deeper, even though the 55 was louder. It was definitely louder at like 40 hertz, but the 2300 actually played a bit deeper.
Because the Z906 was supposed to be the successor to the Z55, but I...
Oh, sorry. Sorry, are you saying Z50? I thought you were saying Z5500, like the 5500.
Yeah, but I'm saying they let out another one called the Z906. That was supposed to be the successor to the 5500, I think. Yeah, but I didn't think it was all that.
I don't think I ever saw it. I quite liked. I heard a Z4. They made a Z3 and a Z4 computer speaker set, which was a couple of little on-desk satellites that had, I think it was one active driver and 2 little passive radiators, and then the sub for the Z3 and Z4 was a 4th order passive radiator. So it was, if you think about a 4th order where you've got a sealed chamber behind the sub and then a port in the front, it was that, but the port on the front was not a port, it was a passive radiator. So yeah, really interesting design, and actually sounded really good for its size. I was quite impressed. It just sounded really smooth and punchy and musical. Pretty cool.
Crazy.
My 5 Z55s did a 149 on my meter. What meter have you got? Is it one of the proper pressure ones at 58 to 60 hertz in my car? A 149 from... I'm a little bit skeptical, not gonna lie, although it is at high frequency.
No,
60 hertz.
I've seen it. He was in some bunker. Nah, it was ridiculous.
Really? Actually, no, yeah, thinking about it, at 58 to 60 hertz, probably.
The resonant frequency of that, it was ridiculous.
No, yeah, okay, I can imagine that, actually. Well, what size driver are they 10s, aren't they? 5 10s at 60. Yeah, it probably did do almost a 150, actually. Yeah, probably did.
I don't think an XT15 would be a good idea, man. Because if you think about it, you share a 15 with this size magnet on it. I don't think it's gonna be a good idea.
Oh yeah, yeah. No, XT15. Yeah. Because if you think about it, when you have a line of sub drivers that share the same coil and motor, but the cone size just changes, well, they're not comparable in terms of like their beefiness. So if you take, for example, the XT8, that is a monstrous 8. That is like one of the best 8s you can buy. But the XT12 is a very low power, mid kind of, it's a great sub, but it's not by any means a beefy overpowered 12. It's like an entry level kind of low power 12. So if you were talking about an XT15, it's going to be really weak. Like the amount of cone area to coil force ratio is very high.
Redesigned.
Yeah. So I think that the XT15 would have to be built like the power drive or something like that to be sort of comparable.
It couldn't be stamped. It would have to be cast, bigger magnet, probably even like a 3-inch coil, not a 2-inch.
Yeah. They'd be fine for XT15s, would be great for like home theater or infinite baffle application or something like that, where you don't need, huge amounts of power. And you could have, obviously, with it being the XT line, the FS would be really low because it would probably be like quite a single layer or just a dual layer spider, and it'd be a lightweight coil. So that an XT15 would actually be probably pretty musical for 15 and play really low, not need a lot of power. It would probably be and it would probably look amazing because it would have the dome, the full dome cone with the carbon fiber effect. Probably would look awesome, a bit like the Dayton Ultimax. It looked like a Dayton Ultimax 15, just a lot cheaper, and it would probably be great for like home theater and stuff like that. But it wouldn't be that great for chucking in your car and sending big power to.
But the amount of stuff we need to do to it, I don't think we could justify calling it an XT.
Yeah.
You know what I mean?
Yeah, I want to check out the Z523s. I haven't seen those. The best ones with passive rad. One of my favorite audio experiments that I've done in recent times is the passive radiator thing that I built. It's a prefab 12-inch box, just like your most basic, like, rubbish, piece of crap prefab 12 sealed box.
6.5 was a machine though.
Yeah.
The depth on it was crazy.
And it's got a an edge 12-inch cone in it that's weighted to be a passive radiator tuned low, and then on the side of the prefab box I've stuck the Digital Designs 1500 series 6, the big beefy 6.5 inch, and that thing is very loud and sounds great, and it's just a lot of fun. It's just a really cool, fun little sub. I don't know, it's nice.
I can't believe how deep that 6.5 was. That was ridiculous.
Yeah, no, they're so deep. It's I think it's deeper than it is wide.
Is the XT6 the only one that has different magnet size? Yeah, so the XT6 is not 90, I think it's a 70 ounce. I have one here actually. Oh.
Can you say happy birthday to my little... Yo! Dixon Mayers, happy birthday. Hope you're having a great 12th birthday, my friend.
So yeah, this is the XT6 magnets. They're 70 ounces, if I remember correctly. So you've got 90 ounce on the XT range, and then you've got 70 for the...
That's pretty nice. That's pretty nice. Yeah, I like the XT6. Had a little play with them. I got a soft spot for small subs, small beefy subs that move a lot. They're definitely got a soft spot.
I think a lot of us in here could agree with that as well.
Have you seen the Sundown Z8 prototype? That thing is deep. Have not seen that. Oh no, wait, maybe I have.